In this video, we will be looking at the mole conversions practice sheet. So let's go ahead and get started. So first, there's some information at the top about how to make mole to mass conversions. And so it says the average atomic masses seen on the periodic table are determined based on the mass of carbon-12. And then another term for average atomic mass is molar mass. So those words can be used interchangeably. And the molar mass is the mass of 1 mole, meaning Avogadro's number, 6.02 times 10 to the 23rd, of any pure substance. And the units of molar mass are grams per mole. So we can use this as a conversion factor to get from moles to grams and then back again. So let's look at the first problem here. It says how many grams are in 1 mole of silicon? And so we can first start by writing down our given value, unit, and substance. So we have 1 mole, and then our substance is silicon. So I'm going to put Si. And then to make our conversion from moles to grams, we're going to multiply by a conversion factor. And in our conversion factor, we first want to fill in our units before we fill in any values. So we want moles of silicon to cancel, so I'm going to put moles of silicon on the bottom. And we want to get to grams of silicon, so I'm going to put grams of silicon on top. So now, if you didn't know what to do here, you could have looked back at your mole conversions chart and said, okay, so the problem is giving me moles and I want to go to grams. So to get from moles to grams, I need to use the molar mass to get from moles to grams. And then from there, you could have set up your conversion factors and then recognize that we need to look at the periodic table to figure out the molar mass of silicon. So silicon is right here, and it says that the molar mass is 28.086 grams. And that's the number of grams that are in 1 mole of silicon. So I'm going to go ahead and put my 1 mole of silicon, and I'm going to fill in 28.086 grams of silicon per 1 mole. So now I have a true conversion factor. There are 28.086 grams of silicon in every 1 mole of silicon. So now I just need to do some math. I can cancel my moles of silicon with the moles of silicon on bottom here, and I'm going to be left with grams of silicon, which is my target unit. How many grams of silicon? So now I'm just going to multiply across. 1 times 28.086 gives me 28.086, and then my units are grams of Si. It's important that we always put a unit and a substance on all values when we are making mole conversions, because a gram of silicon and a gram of carbon are not the same thing. So we need to specify what exactly we are talking about. Let's look at the second example on this sheet. Move the paper up a little bit. We'll put our chart down. This next one says how many grams are in 4.2 moles of aluminum. So we want to get to grams. We're given a number of moles of something. So moles to grams is once again going to require the molar mass. We're going to write our given value, 4.2. And I'm going to leave off that 0, although I know this has 3 significant figures. So we need to keep that in mind. But I'm going to leave, well, I'll go ahead and put it there. 4.20 moles, M-O-L, of aluminum, A-L, times, oh, and we forgot to do sig figs on this first value. So if we round this to the correct number of significant figures, it should have 3 significant figures just like in the problem. So this should be rounded to 28.1 because we need to round to this decimal place here. This 8 makes this round up to a 1. So 28.1 grams of Si. So this is actually our final answer. Forgot a step there. Alright, so we have 4.20 moles of aluminum multiplied by a conversion factor. We know we just need 1 conversion factor to get from moles up to grams. We need our moles of aluminum to go on bottom. Moles of aluminum we want to cancel, and we want to get into grams of aluminum. So to figure out how many grams are in 1 mole, we're going to look at the periodic table. You can see aluminum is number 13 right here, and its molar mass is 26.982. So 26.982. 26.982 grams of aluminum per 1 mole. Put an equal sign. Now we need to make our cancellations. Moles of aluminum cancels with moles of aluminum. We're just going to be left with grams of aluminum, which is indeed what we were looking for. So we probably need a calculator to complete this one. Let's bring our calculator out. So this time we want to put in 4.2 times 26.982. 4.2 times 26.982, and that gives us 1.13 e to the second. I'm going to change the mode of my calculator to be back in normal instead of scientific notation. So that's 113.3224. Okay, but we only want 3 significant figures in our answer, so I'm going to round to this third significant figure here, and the 3 would cause it to round down to a 3, so I'm going to round. I'll actually write out my answer, 113.324, and then I'm going to put this approximately sign and round to 113, and then my units are grams of aluminum. Box my final answer. It's important that we pay attention to our significant figures in these problems. So you might be saying, well, these values have a whole bunch of digits on them. But when we are looking at significant figures, we are only paying attention to the sig figs in the given values in the problem. The decimal places that are on the periodic table we're not using. We're assuming that those are exact values. So we're paying attention to the significant figures in the problem. But for both of these problems, the lowest number of significant figures is actually the value in the problem, so it hasn't been an issue so far. All right, moving on to number 3. How many moles are in 82.1 grams of fluorine atoms? So it's important that this says fluorine atoms, because if it said fluorine gas or something like that, then fluorine is one of our diatomic elements. So we would have to use the molar mass of F2, not just F. But here it says specifically that we're talking about fluorine atoms, just a singular atom. So we can start out with 82.1 grams of fluorine. It's our given value, substance, and unit. 82.1 grams of F, multiplying by a conversion factor. Looking at our chart, we're making that same conversion between grams and moles. We're going to use our molar mass once again. Fluorine has a molar mass of 18.998 grams in 1 mole. Oh, but I haven't filled in my units yet. For source, we need to put grams of fluorine on bottom to moles of fluorine on top. Oh, this one's going the opposite way. So grams of fluorine needs to cancel. We need moles of fluorine to stay. So this time, we're going to put our molar mass, our 18.998 grams of fluorine in 1 mole. We flip our conversion factor upside down. All right, now we just need to multiply and divide out. Grams of fluorine cancels as grams of fluorine. And we, this time, need to take 82.1 and divide by our molar mass. 82.1 divided by 18.998. And that gives us 4.3215. 4.3215. But I only have 3 significant figures in my given value, so I need to round this to 1, 2, 3 significant figures. This 1 makes it round down to the 2, so we have 4.32, and then our units that are left are moles of fluorine, so I'm going to put moles of fluorine. Box that answer in. All right, and last but not least, how many moles are in 367 grams of calcium? So, if we look at our chart once again, this is a gram to mole conversion. 367 grams of calcium is what we're starting with. 367 grams of Ca, calcium. And we just need 1 conversion factor to get it to moles. Grams of calcium needs to go on bottom so that it will cancel. And then moles of calcium and go on top, because that is what we are trying to find in this problem. Looking at our periodic table to find the molar mass of calcium. Calcium's over here in group 2, and it has a molar mass of 40.078. So we're going to put 40.078 grams are in 1 mole. Now we just need to cancel our units and multiply out. So grams of calcium cancels with grams of calcium, and we'll be left with moles of calcium. So once again, we need to divide here. So let's do 367 divided by 40.078, which gives us 9.1571. But we know we need to round to our correct significant figures. This value has 3 significant figures, so we need to round to 1, 2, 3. And this 7 is going to make the 5 round up to a 6. So our final answer will be 9.16. And then our units are moles of calcium. We'll box that final answer. In this next section, we're looking at how to determine the molar mass of a compound. So the mass of 1 mole of a compound is just the sum of the masses of all the particles or atoms that make up the compound. So you just look up the molar masses of each of the elements and multiply the molar mass by the number of moles of that particular element, and then add up all those products. So let's start by just determining how many moles of hydrogen there are in 1 mole of water and how many moles of oxygen are in 1 mole of water. So water is H2O. So in every 1 mole of water, we have 2 moles of hydrogen, and we have 1 mole of oxygen. So when we determine the molar mass of water, we find the molar masses of each of the elements and then multiply them by how many moles we have and then add them up. So for instance, we have 2 moles of H2, so we're going to multiply that by the molar mass of 1 hydrogen, which is 1.008. 2 times 1.008, and then oxygen, we just have 1 mole of that, so times 15.999, which I can show you on the periodic table, 15.999. Now, when we're determining molar masses, you may be tempted to round these values because you say that, okay, it's 1.008, that's really, really close to 1, and 15.999, that's really, really close to 16. And you can round some values on the periodic table. If you have 0.00 or 0.99, then you can round that value. But if you have, for instance, the mass of carbon, which is, or let's do boron, which is 10.811, you should not round that up to 11 because it's too far from the whole number, and you may wind up with a rounding error in your answer. But like nitrogen, 14.007, you can round that to 14. So let's do that here. So let's redo this and do 2 times 1, and then 1 times 16, just to make this a little easier. And water is a very, very common molecule that you will use a lot. So it will be very tempting to round this 1. So 2 times 1 gives us 2 grams, and 1 times 16 gives us 16 grams. So the molar mass of water is 18 grams in 1 mole, per mole. Okay, next let's look at the molar mass of sodium hydroxide. Sodium hydroxide, so we have Na with a +1 charge and OH with a -1 charge. When we crisscross, we get Na1 and then OH. So we have 1 sodium, we have 1 mole of oxygen, and we have 1 mole of hydrogen. So we need the molar mass of sodium, which if you look at your periodic table, is 22.990. Let's see, 22.990. Oxygen, we said, is, we're going to round that to 16. And then hydrogen, we said we can round to 1. So we have 29.990, which we can actually just round to 23. So 23 plus 16 plus 1 gives us 23 plus 16 plus 1 gives us 40 grams per mole for sodium hydroxide. Alright, let's move this out of the way. Move this paper up a little bit so we can look at the next problem. So this next one says, what is the molar mass of glucose with the chemical formula C6H12O6? So first we need to determine how many moles of each element there are in our compound. So we have 6 moles of carbon, we have 12 moles of hydrogen, and we have 6 moles of oxygen. And then we're going to multiply by their molar masses. Carbon has a molar mass of 12.011. 12.011. I'm not going to round that value because it's not a 0.00 or a 0.99. So we are more than 0.001 off. So we're not going to round that. Hydrogen, we said, has a mass of approximately 1, and we can round that one. And oxygen, we said, has a mass of approximately 16. So when we do 6 times 12.001, let's see, 6 times 12.001 gives us 72.006. Hydrogen, 12 times 1 gives us 12. And 6 times 16, 6 times 16 gives us 96. So then we can add all these up together. We can add these all up, plus 96, plus, oops, struggling to use my calculator here, plus 12 gives us 180.006. And at this point I have a 0.00 something, so I'm going to round to just 180 grams per 1 mole. You just want to be careful rounding and make sure that you are not throwing off your answer by a significant amount. We don't want to throw our answer off by more than 0.00 something. If we throw it off by 0.01 or 0.1, that's a significant source of error. So we want to be careful with that. This last one says, what is the mass of 2.35 moles of glucose? So we just calculated the molar mass of glucose, so now we just need to do a little bit of dimensional analysis. What is the mass of 2.35 moles of glucose? So this is a mole to gram conversion, so we just need our molar mass to get from moles to grams. And we already calculated the molar mass, so that's super convenient. So we have 2.35 moles of C6H12O6. And then we're going to multiply by our conversion factor. And on the bottom, we want moles of C6H12O6. C6H12O6. And on top, we want to have grams of C6H12O6. And then we know that 1 mole of C6H12O6 is equal to 180 grams of C6H12O6. So now it's just a matter of multiplying this out. 2.35 times 180 gives us 423 grams. 423 moles of C6H12O6 cancels with the other one, and we're left with grams of C6H12O6. This 423 will be in grams C6H12O6. We're going to box that final answer. Really, we should have boxed all of our answers if we went along, so I'll go back and do that real quick. 18 grams per mole, and then 1 mole of oxygen, 2 moles of hydrogen that we used up here. So in this next part, we're going to look at some multi-step conversions. So if we want to get from particles all the way to mass, it is going to take more than one step. So if we want to go from atoms, molecules, or particles all the way up to grams, then we have to go first into moles and then into grams. So this is going to take 2 conversion factors to get from atoms, particles, molecules all the way up to grams. So here this question says, how many grams are in 4.28 times 10 to the 16th atoms of phosphorus? So when we write our given value, we're going to put 4.28 times 10 to the 16th atoms, there's no abbreviation for atoms, of phosphorus, P, atoms of P. And we know by counting on our chart that we're going to need 2 conversion factors. So I'm going to put multiply by 1 conversion factor, multiply by 2nd conversion factor, and then we'll put our equal sign way over here. Okay, so in our first conversion factor, we want atoms of phosphorus to cancel out, so I'm going to put that unit on the bottom. And we first want to get into moles. And if you forget that, just look back at your chart. First we need to get to moles, so atoms of phosphorus to moles of phosphorus. And then our second conversion factor, we want to get rid of our moles of phosphorus, so we'll put that on bottom. And we want to get into grams of phosphorus, so we'll put that on top. So now we just need to know where to get our values for our conversion factors. So atoms to moles, that conversion factor is Avogadro's number. And remember, there are Avogadro's number of atoms or particles in 1 mole. So for every 1 mole of phosphorus, we have 6.02 times 10 to the 23rd atoms of phosphorus. And I had to put that on 2 lines because it does take up a little bit of space. And then to get from moles to grams, we just use our molar mass. So we can find our molar mass looking at our periodic table. Phosphorus is right here, and it's 30.974 grams in 1 mole. So grams, so 30.974 grams of phosphorus per 1 mole of phosphorus. Okay, so we've done the hard part. Now we have to cancel atoms of phosphorus, cancels with atoms of phosphorus, and moles of phosphorus cancels moles of phosphorus. So we're going to be left with grams of phosphorus, and looking back at our problem, that is what the problem is asking for, how many grams. So now we have to use our calculator to solve this puzzle. And remember, when we type exponents into our calculator, we use a button that either says times 10 to the x or the n or e, and we use that to take up the whole times 10 part, and then we just type in the exponent. So I'm going to put 4.28 e to the 16th, and then I'm going to multiply everything across the top first. So I need to multiply by 1, but that's going to be the same thing, and then multiply by 30.974. So I'm going to do times 30.974, and then I'm going to hit enter and get that first answer, and then I'm going to divide by everything in the denominator. So I need to divide by 6.02 times 10 to the 23rd. So divided by, and I'm going to put it in parentheses, 6.02 e to the 23rd. Close parentheses, hit enter. So this time, my number comes out with a whole bunch of zeros at the front, and this would not be an appropriate way to list an answer. This needs to go in scientific notation. And to make my life easier, I'm going to switch my calculator into scientific mode so I don't accidentally mess up counting my zeros. So this is 2.202 times 10 to the negative 6. 2.202 times 10 to the negative 6. But I need to look back at my problem to know how many significant figures I can have. This value has 3 significant figures, so I need to round my answer to 3. So I have 1, 2, 3, 4 right now, so I need to round to this decimal place. The 2 is going to make the 0 stay a 0 and round down. So 2.20 times 10 to the negative 6, and my units are grams of phosphorus. Box that answer in. So this next problem says how many atoms are in 4.56 grams of neon. So I'm going to start out by writing my given value, unit, and substance. So 4.56 grams of neon. And now I need to figure out how many conversion factors I'm going to need to get from grams of neon to atoms of neon. So I'm starting up at grams, so I need 2 conversion factors. So I put multiply by a conversion factor, multiply by a conversion factor. Now I'm going to set up all my units. So grams of neon needs to be canceled out, and I need to get to moles. So grams of neon is going to go on bottom, and moles of neon is going to go on top. Then my next conversion factor, I need to cancel moles and take my units to atoms. So I need moles of neon on bottom and atoms, A-T-O-M-S, of neon on top. So now I just have to fill in some true conversion factors. So to figure out how many grams are in 1 mole of neon, I can look at the periodic table. Let's see. So neon is over here. Its molar mass is 20.180. So 20.18 grams of neon per 1 mole. And then there are 6.022 times 10 to the 23rd atoms in every mole. So in 1 mole, there are 6.02 times 10 to the 23rd atoms of neon. So now I need to make sure my units cancel. Grams of neon cancels with grams of neon, and moles of neon cancels with moles of neon. So now I'm just going to be left with atoms of neon, which is what I wanted in my problem. So we need our calculator. We're going to put 4.56 and multiply it by everything on top. So times 1, we don't need to do, times 6.02 e to the 23rd, times 6.02 e to the 23rd. Okay, hit enter. And then we're going to divide by everything in the denominator. So divided by 20.18. Divided by 20.18. And then my answer is a really big number, which is to be expected because we're getting atoms of neon. It's 1.360, but I'm going to round there. That's convenient. It already has 3 significant figures. 1.36 times 10 to the 23rd power. And their units are atoms of neon. Now I'm going to box that answer in. There's our final answer. Let's see, move the paper up a little bit. My next problem says, how many molecules are in 10.2 grams of sodium chloride? So how many molecules are in 10.2 grams of sodium chloride? So sodium chloride, now I need to do my crisscross. Na with a +1 charge, Cl with a -1 charge, so we get NaCl. So we start with 10.2 grams of NaCl. 10.2 grams of NaCl. And then we know we need to get from grams all the way to molecules. So grams all the way to molecules, it's going to be 2 steps times 1 times 2 conversion factors, and then we'll have our answer. First, we need grams of NaCl to cancel, and we need to go to moles. So grams of NaCl goes on bottom. Moles of NaCl goes on top. And then we need to go from moles into atoms. So moles of NaCl we need to cancel. And we need to go to molecules of NaCl on top. Now we need to fill in our numbers. So in every 1 mole of NaCl, there's some number of grams, and we need to add up the molar mass of Na and the molar mass of Cl. So Na is over here, it's 22.99, so we can actually round that to 23. So 23 grams plus chlorine's molar mass, 35.453. 0.453 grams. That gives us a total, if we use our calculator, 23 plus 35.453 gives us 58. 58.453 grams. So we know that that's the number of grams in 1 mole of NaCl, 58.453. Alright, now we need the number of molecules in 1 mole, and we know that that's always 6.02 times 10 to the 23rd, Avogadro's number of molecules. Now we just need to multiply and divide. So we have 10.2 times Avogadro's number on top, 10.2 times 6.02 e to the 23rd, divided by what is on bottom, so divided by 58.453. That gives us 1.05 e to the 23rd. 1.05 times 10 to the 23rd. Now this already has 3 significant figures, which is what was in our given value as well. So grams of NaCl cancels with grams of NaCl, moles of NaCl cancels with moles of NaCl, and we're left with molecules of NaCl, which is what we wanted. Let's write molecules of NaCl. Box that answer in. Alright, on to the next one. It says, which of these representations of matter can we measure in lab? And what device do scientists use to measure the matter? So, let's think about this for a second. So, can we measure particles in the lab? Can we count out particles? Well, no, because we can't actually see one single particle, so we can't really count those out. So it can't be particles. What about a mole? Can we measure out a mole? Do we have a device that we can use that tells us how many moles we have? Well, that doesn't really exist either. So let's think about grams. What device do we have that can measure grams? Well, we know that we have an electronic balance that we can use to measure grams. So yes, we can measure grams, but we can't measure moles or particles. And the point of this is that we have to have conversions between all these different units so that we can actually measure how much of something we have. It's important to be able to think about a chemical reaction in terms of what the particles are doing, what one molecule is doing with another, but we also need to be able to measure how much of something we have. And to do that, we need to be able to measure out grams and then convert it into moles and particles. So an electronic balance we use to measure out grams. Okay, next one says, explain and show how you would go about measuring out 2.4 times 10 to the 22nd formula units, which we know a formula unit is just another word for a particle. Okay, so let's think about this. So we can't measure out particles. We need to get it into grams so that we can actually measure out how many particles of table salt we need. So we're going to have to take this value and we're going to have to make some conversions in order to get it into grams, so then we can use an electronic balance to measure out that exact number of grams. And we know that it will be equal to 2.4 times 10 to the 22nd formula units. So we first need to take this and convert it into grams. So formula units, atoms, molecules, particles are down here, and we need to go up to grams. This is going to require 2 conversion factors. So 2.4 times 10 to the 22nd formula units of table salts. And we know table salt is NaCl. NaCl. And the first step that we need to take is to get this from formula units into moles. So we're going to put formula units on the bottom, formula units of NaCl, and then we're going to put moles of NaCl on top. And our second conversion factor, we want to take our moles and convert it into grams. So moles of NaCl goes on bottom, so it will cancel, and then grams of NaCl go on top. Okay, so we need to fill in some values. So we know that there are 6.02 times 10 to the 23rd formula units in every 1 mole. And we know that 1 mole, we just determined earlier, equaled 58.453 grams by adding up the mass of Na and the mass of Cl. 58.453 grams. Okay, so now we can figure out how many grams of NaCl are equal to 2.4 times 10 to the 22nd formula units of NaCl. We need to multiply and divide. So let's move this up a tiny bit so we can look at our calculator. 2.4 e to the 22nd times 58.453. Enter. And then divided by 6.02 e to the 23rd. Divided by 6.02 e to the 23rd. Okay, and that gave us 2.33 e to the 0. So times 10 to the 0th power, so times 1. So this is equal to 2.33, and then to figure out our units, formula units of NaCl cancels out, and then moles of NaCl also cancels out, so we're left with grams of NaCl. Okay, so now that we figured out our number of grams, now we should write our list of steps. So step 1, convert formula units to grams. And then step 2, use an electronic balance to measure out 2.33 grams of NaCl. Alright, there we go. Alright, number 15, let's see. What is the mass of 0.456 moles of calcium bromide? Okay, so we have moles, 0.456 moles of calcium bromide. Calcium bromide, calcium has a +2 charge, bromine has a -1 charge, so calcium bromide is going to be Ca1Br2. Okay, so we have 0.456 moles of Ca-Br2, and we need to get to mass. We need to get up to grams. So moles to grams, it's just going to be, oh, you can't actually see it, but moles to grams, it's just going to be one step. So one conversion factor, and then we'll have our answer. So we want our moles to cancel out, we want to get to grams. So moles of Ca-Br2 goes on bottom, and then grams of Ca-Br2 goes on top. And we know that we can figure out the number of grams in 1 mole just by adding up the molar masses of each element. So we have calcium, we have one of those times the molar mass of calcium, which if you look at your periodic table is 40.078. 40.078. And then plus the mass of bromine, 2 bromines, and the mass of 1 bromine is 79.904. 79.904. So I'm going to need a calculator for this one. Let's see. So we have 79.904 times 2, and then we're going to add 40.078. So the mass of calcium bromide is 1.99 e to the second. So I move my decimal place 2 times 199.886. 9.886 grams per mole. Okay, so now we have our molar mass. So we know how many grams are in 1 mole of calcium bromide. 199.886. So now we just need to do 0.456 times 199.886. So 0.456 times my previous answer, and that gives us 9.11 e to the first, so we'll remove that decimal place 1 time, or we could just change our mode back to normal. 91.148. 91.148. I need to round to my correct significant figures. This value only has 3 significant figures, 1, 2, 3, and this is going to round down to 1, so 91.1, and then my units that are left, because moles of calcium bromide cancels, are just grams of calcium bromide, grams of Ca-Br2. We're going to box that answer in. Alright, up next, we're getting close to the end here. What is the number of molecules of carbon tetrachloride in 45.2 grams? What is the number of molecules? So we're looking for molecules of carbon tetrachloride in 45.2 grams of carbon tetrachloride. So we're going to start with 45.2 grams. of carbon, just one carbon with tetra, meaning 4 chlorines, CCl4. Okay, and we want to go from molecules, or from grams to molecules, so grams to all the way to molecules. That's going to be 2 steps. 1, 2. All right, let's go ahead and figure out. We know we're going to need our molar mass for carbon tetrachloride. So I'm going to add up those values. Carbon is 12.011. 12.011 plus, and then I need 4 chlorines, plus 35.453 times 4. So our molar mass is going to be 153.823. 153.823 grams per mole. I'm going to put that up there so I have it for later. Okay, 45.2 grams of CCl4. So now we can set up our dimensional analysis. So we first need to take our grams into moles. So grams of CCl4 we want to cancel. And we want to go to moles of CCl4. And then our next, we want to go from moles to molecules. So moles of CCl4 goes on bottom. And then molecules, there's no abbreviation, molecules of CCl4 goes on top. Now we just need to fill in our numbers. So we know that 1 mole equals this number, 153.823 grams. And then we know that 1 mole also equals Avogadro's number of molecules, 6.02 times 10 to the 23rd molecules of CCl4. Grams cancels out with grams, moles cancels out with moles, and we're going to be left with molecules of CCl4, which is indeed what we wanted. So we use using our calculator, let's figure out our final answer. So we need to do 45.2 times 6.02 e to the 23rd. All of our stuff on top. And we divide by the things in the denominator. So divided by 153.823. Close parentheses, hit enter. So that's 1.76 e to the 23rd. And that big number does make sense because we're looking for a number of molecules. So it's going to be a whole lot of molecules. So 1.7689 times 10 to the 23rd. But we need to round to just 3 significant figures. 1, 2, 3. And this 8 is going to make the 6th round up to a 7. So 1.77 times 10 to the 23rd molecules of CCl4. I'm going to box that final answer in. Alright, on to the very last problem. How many moles are in 683.1 grams of silicon dioxide? So here's our starting value, unit, and substance. And we're also going to need to figure out the molar mass of silicon dioxide. I'm going to do this last problem in black because I'm starting to have my writing run all over the place. So we're going to start with 683.1 grams of silicon, Si dioxide, O2. And then since we're trying to get from grams to moles, we just need one conversion factor. Grams to moles, one conversion factor. And it's going to take us grams of silicon dioxide, SiO2, is going to cancel out, and we want to get to moles of SiO2. So to figure out how many grams are in 1 mole, we need to add up all the individual molar masses. So we need silicon is 28.086, 28.086, plus 2 oxygens, so 16 times 2. Times 2, that gives us 60.086. So silicon dioxide is 60.086 grams per mole. I'll put that down here, 60.086 grams for 1 mole. Now we just need to cancel our units, and multiply and divide. So 683.1 times 1 is going to be the same thing. So I'm just going to divide these two numbers to get my final answer. 683.1 divided by my previous answer gives me 11.368. Which I'll write here. 11.3687. And I need to round to 4 significant figures. 1, 2, 3, 4. And the 8's going to make my 6 round up to a 7. So this is approximately 11.37, and my units are moles of SiO2.